All right, guys, today we're going to be looking at the formation of the solar system, a little bit on the Big Bang Theory, formation of galaxies in general, that sort of thing. So, without further ado, here we go. So, the formation of the solar system, there's been many attempts to explain the formation of the solar system, and theories include collisions between celestial objects left behind, eventually came together to form planets. Gravitational forces of stars close to the sun pulled matter away from the sun, causing planets and moons to form. But those are mostly discredited theories. The most accepted theory of how basically all solar systems formed is the solar nebula theory, which we talked a little bit about before in the formation of stars. But anyway, solar system formed approximately 5 billion years ago from a massive cloud of gas and dust, a nebula that began to contract. A possible shockwave from a supernova nearby may have triggered the collapse of that nebula. The sun formed from the disk in the center of the whirling mass of material, hydrogen and stuff like that. Lighter gases, H and He, so hydrogen and helium, pushed away to form the gas giants. The denser clumps of solid matter form the inner planet. So basically, the nebula swirling around, and in the center, the hydrogen and helium collapse to form your star. Some of that hydrogen and helium clump together out further to form your gas giants, and then the heavier elements that was left over, they formed the planets in the interior. All right. So this is your progression right here. So 5 billion years ago, you're on this. And then not too long after that, you're looking at this, where your gas giants are coming together on these outer tracks, and the rocky planets, the terrestrial planets, on the inner tracks. And then eventually you get this solar system. Is evidence to support that theory. All the planets orbit the sun in the same direction. That means they all go around in the same direction, which would make sense that they're all coming from that swirling disk of gas and dust. All planets are on the same plane with the sun in the center. And we observe other planetary systems in various stages of this formation process now that we have the telescopes to do it. And we can also run computer simulations with certain parameters to see if that would actually happen and speed it up to see if it works. We're not going to do this worksheet right now because I don't have that worksheet. All right, so that is in a nutshell how most astronomers would tell you that our solar system formed. What about the universe? The main observation that led us to theorize about the origin of the universe is that the universe is expanding. And by expanding, I mean that all of the other galaxies, so we live in a galaxy called the Milky Way. All of the other galaxies that we can see with telescopes and other instruments appear to be moving away from each other and moving away from us. So if they're all moving away from us, then that means 10 years ago, they were closer to us. 100 years ago, they were even closer to us. Billions of years ago, they theorized that they were all very close. It means that galaxies were once closer together, and you can track them all back to a point zero, where all matter in the universe must have been packed together in one small, super dense, hot mass under enormous pressure. This is not a picture of that. That's just a picture of a spiral galaxy. But that's the main observation. We know for sure that everything is moving away from each other. So if you just kind of mentally play that in reverse, well, at some point in the past, then they must have been very close together. And that led us to the event that occurred when the universe emerged from that state, is known as the Big Bang Theory, when everything, for some reason, moved very quickly away from each other. The energy of the Big Bang is still pushing the galaxies outward. And we know this because not only are the other galaxies moving away from us, they're speeding up. if there was nothing pushing them away, they should slow down and even come back towards us because of the force of gravity. Our galaxy has tremendous gravity, and other galaxies also have tremendous gravity. So they should slow down and then come back towards us, but they don't. They're speeding up, which means something's got to be pushing them forward, away from us, outward. By studying galaxies that are millions or even billions of light years away, a light year, by the way, is the distance. It's has nothing to do with a year. Well, it's not a time; it's a distance. A light year is the distance that light would travel in a year. Light travels at 300 million meters per second. So I'm just telling you what that is. So billions of light years away, scientists can glimpse into the past and see what the universe was like millions or even billions of years ago. So 15 billion years is the estimated age of our universe, is when the Big Bang was supposed to have happened. All right. And so you get gas and dust. Gravity is now taking hold and forming quasars and other things. Galaxies and stars are forming. And then 10 billion years, you've got these galaxies separating and forming local groups of galaxies. And then eventually you get our nice little solar system right here, just 5 billion years ago. I like this diagram. It gives you a nice picture of what's going on in different time periods. So that's all I have to say about that right now. The reading that I want you to do, I'll have a quick look at it, is really, it's actually not related to the lesson that you just saw, only loosely. What it talks about is the details that I didn't talk about, like what is a star cluster? What are the types of galaxies that are out there? That sort of thing. What is the Milky Way, our galaxy, like? What kind of galaxy it is? What is a quasar? You heard me mention the word quasar just a moment ago. And then galaxy clusters, and then you don't have to answer the questions. Like I said, just read through the section, take from it what you can. So it's almost like 3 separate items here. Now it is related, it's still space and galaxy stuff, but I wanted to teach you about the formation of the solar system and the Big Bang Theory. And then I wanted you to read about types of galaxies and things like that. That's in section 9.6 in your textbook. And then I want you to watch this program on black holes, which is both entertaining and educational. Same host, the same type of video as that last one that you saw on star stuff, but it's on black holes, how they form, and it actually talks about how other stars die out as well. So it could have just as easily gone with our life cycle of a star lesson, but we're sticking it in here, and that'll do it, guys. So I'm going to sign off. We are almost to the end here. So good luck with that. As always, email me if you have any problems with any of this, okay?